Good morning, welcome to Stobart London Southend Airport. My name's Tim Griffiths and I'm an instructor here with Seawing Flying Club. Many flying clubs are starting to fly modern aircraft such as the Diamond Star, Piper Warriors and Arrows with glass cockpits. But today we're going to fly a Piper Cherokee 180. It's a real classic aircraft and all the pilots here love flying it. Dave, my student's just doing the walk round and I'll be checking the aircraft myself as the commander. And then what we're going to do is head off to the Essex coast near Bradwell and we're going to carry out exercise 17 from the IOPA syllabus. It's precautionary landings with power. I'll be demonstrating how to do it to Dave. It's one of the longest demonstrations we do as an instructor, and then Dave's going to have a go himself. Then we'll come back here to Southend and we'll carry out some bad weather circuits. So I'd like to invite you now to join us by the aircraft.
Dave, I'm Tim's student and I'll be doing the walk round today on the Piper Cherokee 180. The kind of things we look for: the structural integrity, make sure all the flying controls and surfaces are working, to make sure the aircraft is perfectly serviceable for us to go in the air.
It's very important to check every aspect of the aircraft. What I'm doing now, I'm checking that there's no contamination in the fuel. Aircraft are not like cars, where if they break down you simply pull in and call the AA. We as pilots don't have that luxury. We can't park next to the nearest cloud and call for help if we get into trouble. What I'm doing now, I'm checking the air intakes for the engine and the spinner and the propeller to make sure there's no damage on them. And there's the exhaust and the front tyre. Here I'm checking the underside of the wing and the brakes on the actual wheels themselves. Heaven forbid the brakes should fail coming into land, because we would not stop and run into the control tower. The ends of the wings and the navigation lights are important, as are the ailerons and the flaps and the controls that link the ailerons to the controls in the cockpit. Looks like the flaps are serviceable. Then there's the external checks. Make sure the glass is fitted properly and there's no damage to the skin of the aeroplane. There I'm checking the rudder and the rear navigation lights. And there's the elevator and the anti-balance tab that moves with the elevator.
And I do believe we have a serviceable aeroplane.
Dave, my student's done the walk around in the aeroplane and we've seen that the oil level is just below the minimum of 6 quarts. The aircraft's got about 10 hours or so until its next 50-hour check, so it's obviously burnt a little oil off since it was last checked. So this is perfectly normal for a light aircraft. So what I'm going to do now is I'm just going to put another quart of oil in before we go flying. Settle in. The oil we use is called AD80, and the 80 stands for the viscosity of the oil, and what that means is if we had a column of the oil 1 meter tall, it would take a certain size ball bearing approximately 80 seconds to sink from the top to the bottom, and that's how they measure the viscosity of oil. Well, we've done the walk round of the aircraft now. We're just waiting for the fog and mist this morning here at Southend to lift, and then hopefully we'll be able to get underway with our detail. So we thought we'd just show you around the cockpit of the aircraft. Obviously here this is the control column, and this is what we use to manoeuvre the aircraft, the elevators and the ailerons. Down by my right leg here we have the flap lever, and this is what we use to select the 3 different stages of flap we have: 10 degrees, 25 and 40 degrees. We have the parking brake here, and then in the center quadrant here we have the throttle lever, the engine mixture control and the carburetor heat. Across the electrics panel here we have the electrics master switch, and we have various electrical switches So the fuel pump landing light, the anti-collision beacon, the pitot heater, and the navigation lights and internal panel lights. The primary instruments here are what we use for flying the aircraft. This is the airspeed indicator, and it shows us our indicated airspeed. That's basically a function of the aircraft's aerodynamic performance. It's calibrated in knots on this aircraft. You can see it's got a green arc round here, which is our normal operating speed range. It's then got a yellow arc, which is the speed range we can only fly the aircraft in still air. The red line here at 149 knots indicates the aeroplane's never exceed speed. We have a white arc here, and this speed range here is what we call the flap operating speed range, and the top of it here at 100 knots, that's the maximum speed we can fly with the flaps out, and at the bottom of it here, that's the aircraft stalling speed with flaps extended. This is the artificial horizon, and it gives us the aeroplane's pitch information with regard to the horizon. It's driven by an engine driven suction pump. The engine stopped at the moment, and that's why you can see it's toppled like this, but when we're in flight that'll come what we call erect, and it'll show us our pitch information. Here we have the altimeter. It's currently set to the approximate sea level pressure at Southend here and reading 50 feet, which is the airfield's elevation. This is our vertical speed indicator. It shows us our rate of climb and descent in hundreds of feet per minute. This aeroplane's got quite a powerful engine, so when it's just two of us in it, we get quite high rates of climb on it on climb out, particularly on a cold day like today. And this here's our directional indicator, which we align with the compass up here about every 15 minutes or so in flight, and it gives us our heading. Down here, if you can see, is the turn coordinator, and this helps us carry out what we call balance turns, and it's also quite important when we're flying by sole reference to instruments. It allows us to carry out what we call rate 1 turns using these marks here. This instrument over here is the aerial direction finder, which we can tune into non-directional beacons on the ground. Some navigation instruments here that we can use for tracking VORs, and this one here we can carry out instrument landing system approaches on. These are our radios here. We have a Garmin 430 GPS and a secondary box. This is the ADF here. It's quite an old one in this aircraft, but it is in fact a very good ADF. And finally the transponder, and beneath those here we have our circuit breakers. Hopefully the mist will be lifting soon and we can get airborne.